All right, guys, welcome to it, your almost favorite YouTube channel, Mathematics Gurus. So now I just want to focus on application of the trig ratios. So we all explored sine theta, cos theta, tan theta, and then their reciprocals, which are for sine. The reciprocal of sine is cosec. Then the reciprocal of cos is sec. The reciprocal of tan is cot. Right. So we all know that using our mnemonic so ka toa. Using our mnemonic, right? So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, then tan is opposite over adjacent, then cosec is the reversal of that, which is h over o, reversal of that h over a, then the reversal of that is a over o, right? Okay, so these are the things that I want us to apply. So as I wrote, my topic is application of those things. So for example, let's say they give you a triangle, right? A triangle, right angle triangle, right? Remember, bear in mind, these ratios can only be applied on a right angle triangle. So for example, they will tell you that find, let's say here it's 30 degrees, right? And then here the longest side is 5, right? And then they say use let's say this is x, this is y, right? You remember from our Cartesian plane, if I extend these lines, then I have my Cartesian plane, right? Like this. So this is x. Let me just say x1. Don't mind my x1 and y1. Just focus on this thing that I want us to find. So they say to you, use trig ratios. Using trig ratios, find y1 and x1, right? So the question is like that, right? So what you need to do here is ask yourself, this angle is right here, right? So which one is opposite to this angle? It's y1, right? So in order for us to find y1, we need to apply opposites and hypotenuse, right? Which trig ratio talks about opposite and hypotenuse? There's our trig ratio. It's this one, sine. So in order to find y1, we're gonna say sine 30 degrees, right, is equal to, why am I saying 30 degrees? You remember on the triangle that I used as our example on that previous video, we said theta here. So this theta 90 degrees and then 90 degrees minus theta, right? So here if you say 90 degrees minus 30 degrees, you're gonna find 60 degrees, right? Right. So sine 30 degrees, right? You're gonna get y1 over hypotenuse, right? Our side now has a name, and our hypotenuse, we already know what it is, so let's just substitute it, y over 5, right? So in short, let me summarize that. Sine 30 degrees is equal to y1 over 5, right? So using our algebra, we multiply both sides by 5, because since this is dividing, so we have to multiply by 5 both sides in order for us to be remaining with y1 only here. So y1 is equal to 5 times 30 degrees. Okay, let's press that in a calculator. For now, I'm gonna show you the tricks of how to find these special angles. I'm gonna show it to you after this video. So we have 5 times sine 30. So our y1 is 5/2, right? That's our y1. Then as for x1, we so indicate here this is 5/2, right? So as for our x1, we have to use the one that has adjacent and hypotenuse. So that's cos, because cos talks about adjacent and hypotenuse. So cos 30 degrees is equal to x1 over 5, right? So when you multiply by 5, you isolating x1 is equal to let's press in the calculator again, cos 30, right? There's our answer, 5√3/2, right? So those are just like an example. It's not really gonna show up like this in your questions. So now I want us to move over to how to the different types of angles that application of trig usually requires in a lower level. So we have special angles of 30 degrees, 45 degrees, 90 degrees. Let me just indicate like this. One, okay, let me see. After this, we have 180 degrees special angle and 360 degrees. Oh, I forgot 270 there, 270 somewhere there, 270 degrees. Yes. So like these ones, like they just mainly they focus on 30 degrees. Oh, I forgot also 60 here degrees. So mainly they focus on 30 degrees, 90 degrees, 60 degrees. I mean, I'm getting sloppy now. And 90 degrees, right? So they focus on these 4 most of the time. So where do they actually get these things? So let's see, where do they actually get these things. This was a previous video, so now let's focus on where do they actually get these things, right? So they have like I told you, we're using right angle triangle, right? Now these measurements of this right angle triangle, it doesn't just come out of nowhere. The right angle triangle comes from an equilateral triangle. We all know what is an equilateral triangle. An equilateral triangle has 60 degrees, right? We all know that it has 60 degrees and all those things. So if we were to draw a line here, right, we will be dividing this angle into 2. So we will have 30 degrees here and 30 degrees here, right? So that's how it is. And then this line, as you can see, it's perpendicular to this point here, right? So it's gonna be 90 degrees. This triangle is 90 degrees. This triangle is a right angle triangle, also 90 degrees, right? So that's how they find this right there. Now we all know a right angle, an equilateral triangle. That's how they measure it. They measure it with 2, 2, 2. All sides are equal in a equilateral triangle. We all know that. So now from here, since they divided this one, so we're gonna have to divide this 2 into 2 into two parts, so it's gonna be 1 and 1 here, right? Using this triangle, then they find the side to say what is this side equal to, using Pythagoras theorem. Pythagoras. So using Pythagoras, we isolate the triangle. I'm gonna start with this side taken from that triangle, right? 90 degrees, right? So we have a 2 here. It's the same triangle there. So we have a 2 here and a 1 here, and then a 60 degrees here, a 60 degrees, and then here obviously it's gonna be 30 degrees as indicated there. So using Pythagoras theorem, we say hypotenuse squared is equal to opposite squared plus adjacent squared, right? So from here, the hypotenuse is given is there. It's 2 squared is equal to the opposite. We don't know the opposites, but we know the adjacent, which is 1 squared, right? So 2 squared is 4, right? O squared plus 1 squared is 1, right? Then we transpose whatever way you want to do it, but then the shortcut for me is like this. And then we have 4 minus 1, right? 4 minus 1, right? So here we're gonna have O squared is equal to 3, right? And then they square root both sides, right? Square root of 3 plus or minus, right? So we're gonna have plus or minus, right? That's how it is, plus or minus as I indicated, right? So this plus or minus square root of 3, right? It comes here. The reason why I'm using plus or minus is because, remember, when dealing with sine theta, cos theta, and tan theta, they all depend on which quadrant you are located in. Remember, we talked about these quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? So we all know sine is everything here is positive, right? And then sine here is positive, and then tan here is positive, and then cos here is positive. So the reason why I'm using plus or minus is to indicate which one is negative where and which one is negative. I'm going to explain that later. So for now, let me just continue with this one. So let's say they say find sine theta using this triangle, right? Sine theta. But then in this case, let me not use sine theta. Let me use sine 60 degrees. Sine 60 degrees is equal to we go to our triangle. There's our opposite side, which is square root of 3 over our hypotenuse, which is 2, right? Without using a calculator, that's how you can find it. Then, just to check yourself if you're correct, sine 60 degrees square root 2 over 2. There's square root 2 over 2, right? So let's say you're using this triangle again. Then they say, standing from this viewpoint, from this top point here, what is sine 30 degrees, right? Sine 30 degrees is equal to what? We have to look across, which is our opposite, 1 over, and then our hypotenuse is 2. So simple, 1 over 2. Then you can check that on your calculator. Sine 30, 1 over 2. Basic things, guys. And then for cos, let me do cos here so that you can see the difference and notice that sine is a co-ratio of cos. They are co-ratios. I'm gonna explain that. let me write it down. Sine theta is a co-ratio of cos theta all the time. That's how it is. So now let me prove myself right. So cos 60 degrees, go there. We're standing here. What's our adjacent? This is our adjacent, which is 1, right, over our 2, right? Look at it. Cos 60 degrees and then sine 30 degrees. They have the same answers. So that's where co-ratio comes in. Like, what I mean by co-ratio is that if you have sine 90 degrees minus 30, right, you're gonna have cos 60 degrees, right? That's how co-ratios work. Basically what they mean in grade 12 is that this co-ratio, this 90 degrees changes sine 90 degrees, and then it checks which quadrant is this. It's in quadrant 1, 90 degrees. Like in quadrant 1 we have 90. Oh, sorry about that, I was rudely disturbed. So this is how you figure out that thing of 90 degrees. So 90 degrees minus theta is in the first quadrant, and then 90 degrees plus theta is in the second quadrant. 180 degrees plus 180 degrees minus theta is in this second quadrant, then plus, and then 360 here minus theta, obviously, and then 270 plus theta. So basically what we mean is that 90 degrees below, it's 90 degrees below, right? And then here is 90 degrees above, but it's also 180 degrees below. That's why we say minus. And then here it's 180 degrees above but 270 degrees below. And then also here it's 270 degrees above and 360 degrees below, right? So that's how you distinguish those things. So then we have this special angle of 45 degrees, right? 45 degrees, right? Here it's also 45 degrees, right? Because when it adds up it must be 180 degrees. So here the basic things, so as you can see here, we basically have like an isosceles triangle with this angle equal to each other. So the isosceles triangle is somewhat sideways. So here this side is equal to this side, right? So we're gonna, it's 1, right? And then also here it's 1. Using Pythagoras theorem, we're gonna say hypotenuse squared is equal to O squared plus A squared, right? We don't know the hypotenuse, that's the one we want to find. Then 1 squared plus 1 squared, right? So we have A squared is equal to 2, right? And then when you square root both sides, it's gonna be H is equal to plus or minus square root of 2, right? So that's how it is. Then here it's just square root of 2, plus or minus square root of 2, right? Okay, so when they say sine 45 degrees, right, they mean to say sine 45 degrees is we stand here on this viewpoint, right? So to find this side, which is 1, right? So 1 over the hypotenuse, which is the longer side, which is square root of 2, right? So that's how sine 45 degrees is. But then you calculate, your calculator, it rationalizes this. By rationalizing, this is what I mean. It multiplies by root 2 over root 2, right? That way the square root cancels each other, and then 1 times square root of 2, you have square root of 2, and then the square roots are cancelled, so you're gonna have 2, right? That's how it is. So that's how sine 45 degrees looks like. You can check that even in your calculator. Sine 45 is square root of 2 over 2. And then cos, obviously, since it's a co-function, it's a co-ratio, I'm just gonna jump straight into it. So adjacent is 1, and then when your calculator rationalizes, and then you have square root of 2 over 2. That's how it is. So that's how basically everything is found. Like, these are just the basic special angles. Basic special angles. That's how they found. Okay, so on this one, continuing here, let me just wrap up. So 30 degrees is equal to the reciprocal of that, I mean the core ratio of that. So this and this, this and this. So if you can keep this in mind, and then you're sorted. Thank you so much for tuning in. I know in this video we had a lot of disturbances, but res life, guys.